Okay, so in the last lecture, we were talking about how we figured out inverse trig, and we talked about the domain restrictions, and we did a few examples. We're going to continue on with a few examples with some more applications of inverse trig. And so this is kind of a part of what we did yesterday, but I wanted to do one more today just to reinforce it. Okay, so tan inverse of tan of 11 pi over 9. Now, the arctan has a domain restriction between negative pi over 2 and pi over 2. If you want to think about it in the unit circle, then that means that we're going to stay on the right side of my unit circle. So basically, my arctan has to be over here. If this tangent here, this was pi over 9, that would actually be over here. And it would just be, my answer would just be pi over 9 then. But 11 pi over 9, let's see, where would 11 pi over 9 be? So 9 pi over 9 would be pi, so that would put me over here, right? And if it were 12 pi over 9, that would simplify to 3 pi over 2, which would be down here, the same place as negative pi over 2, right? Just going in the opposite direction. So this angle is actually somewhere right here. It's in the third quadrant. That looks like pi over 4, but we're just going to call this, I know it's in the third quadrant, and that's all that I need to really know about it. So what that means for me is that my tangent will be positive. Remember, all students take calculus, so it'll be positive over here. Now 11 pi over 9 is not in the domain of arctan, so it's not 11 pi over 9. So what we want to do is find an angle over here with the same measurement, right? I want it to be positive. Now tangent is positive up here. It's going to be negative down here, right? Because cosine is positive, but that means sine is negative. So that means my tangent would be negative. So I know that my value is going to come from up here. And so the one that would match 11 pi over 9 would be just plain pi over 9. So this is equal to pi over 9, right? Basically, it's going to have the same denominator. We just want it to be in the first quadrant, and so that has to be pi over 9. Okay? All right, so let's move on. So what if they don't match, right? We've all done matching ones, arctan with tan before. Now we have arcsine of cosine of negative 11 pi over 4. Okay, so let's think about this again. We'll draw another circle. Now, this is a composition of functions, right? This is like inside of this one. And whenever we compose functions, we work from the inside out. So let's think about this. So cosine of negative 11 pi over 4. First, I need to know where that is. Okay, so negative 11 pi over 4 is basically 1 pi over 4 step away from 3 pi over 4, because negative 12 pi over 4 would give me negative 3 pi. So that means I'm like 1 step short of 3 pi. So now I'm negative here. So I'm going to go, here is my 0. Here would be pi, right? Here would be 2 pi. And so negative 3 pi would be here, but I was 1 short. So that means I am right here. Okay, so I am once again in the third quadrant. Now both sine and cosine are negative in the third quadrant, okay? So that's a good thing to know. So I know that my cosine value will be negative. So now, what will be my cosine value here? So cosine here, it's a pi over 4, and it'll be down here, right? So if this is some version of pi over 4, which is it's negative 11 pi over 4, I know the coordinates will be 1 over root 2, 1 over root 2, and since they're in the third quadrant, they're both negative, okay? So I can really replace this with this. So we have arcsine of negative 1 over root 2. All right, so now I want to figure out, so this is saying essentially what sine value is equal to negative 1 over the square root of 2. Now we know that, hopefully we know. If you don't, we need to make sure that you're recognizing these and really putting them in your brain here. This is some version of pi over 4, right? Whenever I get 1 over the square root of 4, that's some version of, or 1 over the square root of 2, that's always some version of pi over 4. Now sine is negative, right? So arcsine, the domain of arcsine stays over here. Okay, so we want, now I know that actually if I looked at the entire unit circle, my sine would be negative over here, right? Which would be 3 pi over 4. And it would also be negative, let's see. Okay, so no, actually that's positive over here. Sorry, so no, that's not it. So sine is positive here, and it's negative here and here, right? So how do I know for sure that it's not this one, right? Well, it's because of the limited domain. It has to be this one over here. And so that would be, now technically this could be called, right, what would this be, 7 pi over 4? But I want it to be between pi over 2 and negative pi over 2. So to get here, I would say it's negative pi over 4. So this would be equal to negative pi over 4. So basically I'm looking for the sine value of some angle that's negative 1 over square root of 2, which we know is some version of pi over 4, but it has to be on this side, and it has to be called something between positive pi over 2 and negative pi over 2. And the only one that fits, because it is a function, right, is negative 1 over the square root of 2. Okay, so let's move on from there. Next problem. All right, so we're going to continue in this manner. All right, so this time we have our arc in the center, right, on the inside. And so we always work from the inside out. And so this is a good kind of place for our right triangle sort of information, so that all of this stuff kind of works together. So this arctan of 5 over 12 means that I have some tangent of theta is 5 over 12. That's what it means, okay? So I'm just going to draw a triangle representing this, okay? So I'm going to call this my theta. I could call it theta up here, it doesn't matter, but wherever I put it here. So I know that in tangent, right, this is really the opposite side over the adjacent side. See, so we interchange the meanings of these tangent, right? I could think of it as sine over cosine, but in this case, it's kind of easier to think of it as opposite over adjacent. So that means if this is my theta, my opposite side is over here, and my adjacent side is over here. Now my cosine, the outer function, is really, right, so cosine of theta is the adjacent side over the hypotenuse. Now I know the adjacent side is 12, so I know that this is going to have my cosine of arctan of 5 over 12 will have a 12 in the top, because that's the adjacent side. So now I need to figure out my hypotenuse, and I can do that using Pythagorean theorem. So that means I'm looking for the hypotenuse, so the sum of the squares of the bases, I have 12 squared plus 5 squared, which is 144 plus 25, which gives me 169, which is really 13, right, when I take the square root of it. Okay, so really this side up here is 13, so that means my cosine of arctan, so basically all I need to do now that I have my triangle figured out is figure out what the cosine would be, which would be 12 over 13. Okay? Okay, we'll do another one like that. So this time so that one was cosine of tangent, arc, or inverse. This one is cosine of sine inverse. And so we're going to again start in the middle. Arc sine of 7/9 means I have the sine of theta is equal to 7 over 9. I'm going to use my triangle method here and think, okay, I'll put my theta up here just to be a little bit different this time. And so I know that sine is opposite over the hypotenuse. So that means my 7 is over here, the opposite side. My hypotenuse is opposite the right angle, so that's 9. Okay, so I know that cosine involves the adjacent side over the hypotenuse, so I do need to find this side over here. Okay, so basically this time, this is my x. I have 7 squared plus x squared equals 9 squared. So this is 49 plus x squared equals 81. So x squared is equal to 81 minus 49, which would be 232. So my x is the square root of 32. All right, so that means this is the square root of 32. And you can simplify that radical if you'd like. I'm just going to leave it. So that means that the cosine of arcsine of 7 over 9 is cosine would be adjacent, square root of 32, over hypotenuse, which is 9. Okay? Sorry, could you see all that? Okay. So 7 squared plus x squared equals 9 squared. So 49 plus x squared is 81. I solve for x squared, I get 32. I take the square root, I get square root of 32. That's the length of my adjacent side. And I put it over here. So, and this is like an exact answer. I know that you could put this in your calculator, but I really want the exact answers, okay? Because I want you to know how this stuff works. All right, so moving on. Let's get into some applications. So these are kinds of things that we're gonna use it for that'll show up in different places. All right, so this time I want to find my theta value is my first one. I put this word problem up here a little bit close, but this is a different problem here. Okay, so I want to find theta. So according to my theta, what sides do I have? I have the opposite side and I have the hypotenuse, okay? So that means I probably want to use tangent. Actually, no, I don't. I want to use cosine, right? Opposite hypotenuse. Oh my goodness. Have I said everything wrong at this point? This would be sine because it would be the opposite side and the hypotenuse. So the sine of theta, did I put everything right? Yes, I did. Okay, so sine of theta is 5 over 10. Now that's really 1/2, right? So I can put this like arc sine of 1/2, but this is actually one that I should know, okay? So I have the sine of theta is 1/2. Now I know that there's multiple places where the sine of theta is 1/2, right? So sine of theta is 1/2 at pi over 6, and it's also 1/2 at 5 pi over 6, right? If I think about my unit circle here, let me draw a little one, right? My sine or my y value, so my pi over 6 here will be positive, and my y value over here will be positive. But I know it can't be this one because that is outside of the domain of arcsine. So it has to be pi over 6. There's no ambiguity here because we have restricted the domain, so there can only be one answer. So my answer is in fact pi over 6. Now, if I didn't know what 1/2 was, right, if I had something completely different, which we're going to have in a moment, then I would just put in arcsine of my thing into my calculator, whatever this number is, and I should get this out. But in this case, I do know what the arcsine of 1/2 is. Okay, so we have another one. So let's do a word problem here. We have the line y equals 4/5. X passes through the origin of the xy plane. What is the measure of the angle that the line makes with the positive x-axis? Okay, so I'm going to draw a picture here. Okay, so I know it goes through the origin, right? And if I put in 0 here, I definitely get out 0. So I'm just going to graph my slope like just, rise over run is my m, right? Because that's the number in front of x. So I'm going to move this 4 units to the right, right? This is 4. And so it's actually rise over run. So actually this is 5 to the right and 4 up, right? So I have this. Okay. So I'm just going to connect these dots. So I just plotted a point. I just went and used my slope. So that means I have rise, which is up 4, right, over the horizontal distance, which is 1, 2, 3, 4, 5, and I just plotted a point. And I'm just going to use that triangle that I've drawn here. Okay, I'm really having trouble keeping it in the screen today, aren't I? So okay, so I just took my slope, rise over run, up 4 over 5. There's my triangle. I plotted this point and then I just dropped in the perpendicular here. Okay, so now I did it like this way because now I know what these sides are, right? Or at least a couple of the sides are. I want to know this theta value because it's the angle of the line with the positive x angle. So I have this. Now I know that this height is 4, and I know that this horizontal distance here is 5. So according to my theta, this is the opposite side and the adjacent side. Hopefully I can get it right on the first time this time. The tangent of theta is 4/5. Okay, so now I still need to find theta, so this is where basically my arctan comes in. So that means essentially my x and y just flip here. I get arctan of 4/5. And now I really do have to put this in my calculator. And when I put this in decimals, just like this, I got theta is approximately equal to 0.675 in radians, or approximately 38.65 degrees. Now in radians, I would expect about this, right? Because 1 radian, if you remember, is just slightly under 60 degrees. So this is like approximate, it's a little bit more than half. So this falls right in the ballpark of where I would think it would probably be. Okay, and this angle does look kind of small here. So those are some applications of our inverse trig functions.